Are there any techniques you anticipate becoming even more important in the future to, say, simplify, break down, and come to a complete analysis of these large data sets?
Yeah, so I believe that the way how we solve the models will be slightly different. Yeah, and right now, neural networks are quite promising. We need to let data speak for itself. Yeah, and we should think about computers as a very fast but not very smart person. Yeah, if we need to tell the computers what we want to do in a very exact way. Yeah, so if we say though to make some stupid things, computer will do it, but much faster. Yeah, so we can leverage the fact that some things can be done very fastly, but also we need to be careful what we wish.
Dr. Pytka, thank you very much for taking the time today. I see you've brought an interesting object, which we'll get back to later again. But first, I'd like to talk a bit about your academic background. So you've been at the University of Mannheim since 2018, with previous stations at the Warsaw School of Economics, the European University Institute, and also Princeton University. So what do you enjoy the most about teaching in Mannheim?
First, thanks for having me here. Yeah, and what I like in Mannheim, it may sound a bit cliché, yeah, but I really like students here. Yeah, students are great, yeah, and I feel very lucky that I have an opportunity to interact with such great students, and I'm very happy when I see the progress of students in the course of the semester. Yes, it's a very nice thing, yeah, to see that actually you provide some value added to their knowledge.
And with such interested and curious students, many of them also come from international backgrounds, you mentioned, and I'd say that's certainly the case for me as well. So I've only been here 2 semesters, but I have a very international friend group, and just in general, it's a very international community here in Mannheim. So for you, what is so special about being surrounded by an international community of students and colleagues?
Yeah, so I must say that I'm foreigner, I'm Polish, yeah, and what I really value here in Mannheim is that the diversity of students is really huge. Admittedly, the biggest group of students are Germans, yeah, but in all my courses, yeah, I have students from not only from countries all over the Europe, but even all over the world. Yeah, I had students from both. In every semester, I have students from both Americas, from China, India. Once or twice even I had students from Australia. Wow. Yeah, so actually the only continent from which I didn't have any students was Antarctica. Yeah, and if I were a student, yeah, I would seriously consider this as an additional important advantage of studying here, yeah, because you can get exposed to different cultures, yeah, and you know, being exposed to the bigger variety is something which is better. Yeah,
I 100% agree. That was one of the main factors in my decision to come to Mannheim, and we also have the international semester times here in Mannheim, which offer a lot of flexibility, say for international students who then want to do an internship abroad or something along these lines. So the international perspectives we can gain through intercultural exchange are something I value very highly. So then I'd like to get a bit into your research interests, and your expertise lies in the field of quantitative macroeconomics and big data. And there's more and more data available to the general public and to people in academia in the modern day. So what methods do you implement in your work to attempt to weather the storm of big data?
Yeah, so I believe that from the perspective of students, it is quite important to understand that we live in a world where this data is available more and more at lower and lower prices. Yeah? And actually what I teach here at Mannheim is to try to help students understand the data. Yeah? And in my courses, I try to demystify this whole common narrative, yeah, that those techniques like neural networks, random forest, machine learning, artificial intelligence, all those things are buzzwords, yeah, that can intimidate you. Yeah? And my goal is to show that those are only algorithms that can help us, yeah, and that's my goal here as a lecturer.
So for many people, big data could sound rather complicated, but how do you make sure that you effectively communicate and break down big data and the learnings we can draw from it?
This complementarity between human researchers and machines, yeah, can be used to solve problems previously documented, identified by researchers, but still problematic to address. Yeah? And in the literature, there is such a bias called Rashomon Effect. Sometimes this Rashomon Effect is called a problem of blind man and elephant. So the story that summarizes this bias is that we have blindfold researchers, yeah, that they cannot see the object. Yeah? The only thing that they can do is to touch this object, but only parts of this object. Yeah? And one researcher, which is blind, will start touching the elephant, and he or she will think that it is a snake. The other will touch the leg and will think that, oh, it is a tree. On the other hand, yet another researcher who is also blind start touching ears and will say that, oh, it's a sail of a boat. Yes, so overall, because of the fact that each researcher observes different part of the whole picture, may be biased because of this very fragmented piece. Yeah, and because overall, none of them are correct. Yeah, at the end of the day, there is an elephant and not all those things. Yeah, and actually, yeah, that's a typical problem in many economic models. Yeah, that when we try to study some economic phenomenon, we need to make some decisions about theories that we consider. Yeah, and at some point, very, very early, we start looking through the lens of those models, and sometimes the problem is that we focus too much on one theory instead of considering many theories. Yeah, and that's a problem. Yeah, that many researchers acknowledge that it exists, that we experience such a thing. Yeah, but before the development and emerge of machine learning and increase in computational power, we didn't know how to address this. Yeah, because it was very hard to build models that have many parts, many those stories inside one model. Maybe also what I would like to mention, yeah, and is that yeah, because many researchers say that okay, we can introduce more and more theories, but introducing one additional theory is more and more complicated. There was a very famous mathematician, Richard Bellman, who was a founder of dynamic programming. Also, he was quite famous for being a junior member of Manhattan Project. I don't know. Have you watched Oppenheimer by Krzysztof?
Yes.
Yeah. In my opinion, this movie is much better than Barbie. Yeah, and Richard Bellman was a member of this Manhattan Project, but also after this Manhattan Project, he developed dynamic programming, and he observed a problem that he called the curse of dimensionality. Yeah, that if we introduce one additional component to our models, the complexity is becoming increasingly complicated. Yeah, and machine learning actually can help in addressing this problem. Yeah, that we can start with building a model that have at the very beginning have all possible theories that we want to consider, but at the stage of building this very complex model, narrows down. Yeah, so the algorithm, our machine learning algorithm, decides which channels are more plausible than others. Yeah, and then it stops learning towards those directions. Yeah, so instead of trying to build one very large model which covers everything, yeah, that we have that we want to have a model of all things that we observe outside the window. Yeah, it is physically it's impossible, and also it's not useful. Yeah, because also you need to think about models that it is like a map of the area you want to study. Yeah? And if you're going for hiking to Schwarzwald, yeah, then a map in the scale 1:1 wouldn't be very useful because it wouldn't fit your pocket. Yeah, that it would be too detailed. Yeah, so machine learning algorithms allows us to keep only those things that are important.
That sounds super interesting. So going back to that horse race you mentioned of competing theories, how do you think big data will impact economic policy making in the future?
Yeah, so in general, I believe that right now our discipline is becoming more and more data-driven. Yeah, in the past, because of data scarcity, researchers didn't have access to data. Yeah, and they needed to build sometimes a very stylized very stylized models. Right now, we can address many research questions and look directly into data. Yes, so many people stress that we need to let data speak for itself. Yeah, and so I believe that with the development of big data and machine learning, it is more and more possible. Yeah, and the only thing that I believe that it may be problematic is that in comparison to some hard sciences like physics, where the standard for empirical investigation are laboratory experiments, in economics, it may be a bit problematic. Yeah, because what would be nice to understand, for instance, the cost of job losses would be to organize an experiment. Yeah, an experiment when you have control group that work, they are not fired, and the random sample, random group of people are fired for no reason. Yeah, and it would be very unethical. Yeah, why those people were fired and not the other. Yeah, but so for this reason, in empirical literature, we try to find some events that can work as proxy for those experiments. Yeah, and then using those events and large amount of data, we can try to test different theories. Yeah, but while testing those theories, we can be theory agnostic. We don't say that we are all of us have some preferences. Yeah, I have some of my models are my favorite models. Yeah, and I believe that those are true, or I wish they were true. But I'm very upfront. Yeah, and I believe that we should be not attached to those theories too much, and we should let data speak for itself. We live in this time, in this stage of development of economics, that it is more and more data-driven. Also regarding building for policymakers, what I really think that it is the future, it's not the future, it's the current state of the world, is that either some people use some events to analyze from data that we observed in the past to assume that those things are as if they were laboratory experiments. But another solution is to build your own mathematical model which is solved using computers, and then instead of firing random number of people in the real world, we can fire random number of people in our program, in our, whether it is Julia program, MATLAB program, or R. Maybe R is better for analyzing data and not for building mathematical models.
So you mentioned wanting to let data speak for itself. So how have new approaches or findings in that field, say, changed the way you approach questions or problems that you're dealt with?
I should reiterate this once again. So everything right now should be a horse race between different theories. You shouldn't be attached to one particular channel too much. And we should look more into data if data is available, or we should build some stylized models. But also it is important that in the past, and this is what I mentioned about the curse of dimensionality by Richard Bellman, was that we cannot introduce too many theories at once into our mathematical models, because our program are becoming too complex to solve, and we can be overwhelmed with all those bugs and errors that we get during solving those models. And the solution to this is to introduce selection of channels that are more promising or less promising in the stage of solving those models. So previously it was that researchers were using that, they were saying that, okay, I have the model with those theories and I make this model as similar as possible to the real world, and then I make some claim about what are implications of those theories. What I believe that in the future will be the common practice is that instead of building the final version of the model, we will let the computers, the algorithm, to decide which theories are more promising or less promising for explain the real world.
Are there any techniques you anticipate becoming even more important in the future to, say, simplify, break down, and come to a complete analysis of these large data sets?
So I believe that the way how we solve the models will be slightly different. And right now, neural networks are quite promising. They are used for building ChatGPT large language models, or for image recognition. If you take iPhone, I take a photo of my dog, and in the on the bottom on my iPhone, I see that, oh, it's a photo of a dog, and so neural networks in the real world, in the private sector, they are used quite commonly, but in academic research, still we try to implement this, and I believe that those methods can be used to make the way how we set parameters of the models, parameters in the sense that how we decide which channels are more or less important, it can be decided by machine learning algorithms. At the same time, and this is also referred to this demystifying part that I mentioned before, is that we cannot think that machines are some geniuses that are better than us. And I keep telling students that we should think about computers as a very fast but not very smart person. If we need to tell the computers what we want to do in a very exact way. So if we say though to make some stupid things, computer will do it, but much faster. So we can leverage the fact that some things can be done very fastly, but also we need to be careful what we wish.
For students who are interested in both economics but love data, what can you tell them about your experience, say, starting in research and academia, maybe some advice you would have for them?
I do really believe that it is important that students will get some exposure to programming as early as possible. Yeah, and that being said, also I must say that recently artificial intelligence can be quite useful for building another models, either structural models or artificial intelligence models. So for instance, in my PhD course, right now, I give the large problem to solve for my students, yeah, but I ask them to write the code that solve this difficult model, but using ChatGPT or GitHub Copilot as a tool that will write the code for you. Yeah, and so it is like inception. Yeah, that you have. Yeah, you ask some program to write another program.
So how has research work changed then since you did your research, and how you are experiencing the research of, say, your master's or PhD students?
Many things change quite a lot. Yeah, so when during my master and bachelor studies back in Warsaw, yeah, actually I must say that I was taught more machine learning and data science back then than it was the case at other universities. Yeah, so it was, you can think that I was in a sort of hipster program. Yeah, that before, because we were doing this before it was cool. Yeah. But even back then, the amount of effort you need to put to learn some new tools was much higher than nowadays. Yeah, nowadays we have access to so many resources on the internet, yeah, and the documentation is so well written. Yeah, there are so many tutorials, data camps, yeah, YouTube videos where you can watch some introduction to those techniques. Yeah. By the way, I should mention, yeah, that for my bachelor's students, I pre-recorded some of my lectures, yeah, and uploaded to YouTube, yeah, and yeah. Back then, it required a bit more effort, yeah. Right now, still it is quite demanding, but also with all those resources that we have at hand right now, we can do much more, yeah. And yeah, so I can say that sometimes when I read the master thesis that I supervise, yeah, I'm quite excited and surprised that students with only few courses or few months of working with those methods, they can generate so many interesting results. Yeah.
So having learned a lot about your research now and your expertise, I'm curious about the overlap between, say, big data and your personal life. So when you're not lecturing or researching, does your everyday life also revolve around the methods in your work?
Yeah, so I try to leverage those methods as much as possible. Yeah, and I want to tell you that when I go to grocery store, I just equalize marginal utility of apples and bananas. Yeah, that's not the case at all. Instead, I try to use those prediction methods that I teach to make predictions about the valuation of my portfolio of stocks or cryptocurrencies.
So when I asked you to bring an interview in the email, you said you were bringing a Raspberry Pi, and I was expecting kind of like a cake, but you ended up bringing this. So what is this Raspberry Pi?
Yeah. So actually, it may be quite confusing. I like cooking, yeah, but I think that this is more consistent with my nature. Yeah, it is single board computer. Then there is portfolio of all my stocks that I have, and because at some point I had I checked my trading app, and I was very unhappy about what are returns on those stocks. Yeah, it was computed in a very weird way, and that if students would submit such a report to me, I would say, please redo it. Yeah, and so for this reason, I had this do it yourself project, where I try to make predictions about future growths of all my instruments that I have, yeah, and I understand how it was computed, yeah, and I know what it is exactly, yeah. Every day I receive an email report.
So you get a daily stock update from the Raspberry Pi,
Yeah,
seeing
yeah.
how well your stocks are doing.
Yeah, yeah.
And how satisfied are you with the predictions of the Raspberry Pi you created?
I'm not at this stage that I wouldn't let this Raspberry Pi to trade for my, instead of me. Yeah,
For
that,
you,
for
okay,
you. Yeah.
yeah.
So it's not like automatic trading. Yeah.
Yeah.
It is like more that it provides more insight that then I make human decision. Yeah, and
Okay.
and choices. Yeah.
So in that case, would you say that AI should be more, or should have a role of augmenting human experience and knowledge rather than replacing it? Or what do you see the future in that sense?
Yes, also. So I believe that the future is cooperation. Yeah, and I believe that more and more things can be automatized. Yeah, but still I believe that there is a huge room for people to make decisions, to take responsibilities for those recommendations provided by algorithms. Yeah, and the whole point is that people need to understand how this recommendation was created, what was what were the criteria for making this decisions. Yeah, so still I believe that we don't live in a world where there is a risk of Skynet taking over the world. Yeah, and yeah,
So not quite sci-fi movie level yet.
I like sci-fi movies, but more realistic. Yeah, some people, some economists claim that actually the whole artificial intelligence thing, through the lens of economic models, should be considered as the substantial decrease in cost of making predictions. Yeah, so those people say that the cost of prediction is lower, so let's use more those predictions. Okay. But still, I believe that on top of this, yeah, there is a huge room for people, yeah, to take responsibilities for all those recommendations, yeah, because at the end of the day, there is a guy that needs to press the red button, yeah, and he or she will be judged whether it was
the correct
decision or not.
So you talked about the reports you get from your Raspberry Pi. So what will kind of be the dream data set for you to analyze?
The dream data set would be the future prices of Bitcoin. Yeah, that's the easiest thing. Yeah, but joking aside, I would consider that what I said before about laboratory experiments. Yeah, so in economics we face this problem. Yeah, that sometimes we don't have access to perfect experiments. Yeah, and my dream data set would be a data set that reports some perfect experiment. Yeah. So in particular, in my dream data set, I would like to have access to consumption decisions made by people that received, randomly assigned, some amount of money. So some like lottery, yeah, that there is a group of people that receive those checks, and there is another group of people that don't receive this. And then I would like to observe all consumption decisions that they make. How much they make more savings, how much their consumption increase, what products they buy, at what prices, whether those prices are higher or lower in comparison to a situation where you don't buy those products, in what stores you buy. So in general, in my dream data set, yeah, I would like to have a report which is a result of something which is as close as possible to laboratory experiment. Yeah, in other studies, some people use lottery gains. Yeah, and they say that it is like some experiment. But the problem is that whether seriously you think that people that buy those lottery tickets are the same as people that don't buy, we don't know. Yeah, and so I think that would be an amazing data set for me to study, and to have all those information. Yeah, and I would be like a big brother of consumption. Yeah.
So now, as we're kind of getting to the tail end of our conversation, I wanted to ask you, what do you love the most about living in Mannheim?
I'm really happy that I can work with such great students. Yeah, but also I can say that the area where Mannheim is located is really nice for bike trips. Yeah, and I'm a big bike enthusiast. Yeah, and actually when I moved from Florence, located in Chianti, which is famous for cycling, yeah, to Mannheim, I was very positively surprised by the infrastructure. This infrastructure is amazing, yeah, and there are many interesting roads, yeah. In the middle of COVID, even I organized a few-day trip from Mannheim to Rotterdam, and I was surprised that most of this road was on proper bike lane. Yeah, from this perspective, I really like this area. Yeah, because you have Pfalz, Schwarzwald or Black Forest is also amazing, but mainly for hiking. Yeah, because I'm rather endurance cyclist rather than a mountain biker. Yeah.
And where's the favorite, say, either location or route you've cycled on?
I like variety, yeah, but if I don't know where to go, then I take my bike and I ride directly to Heidelberg. Yeah, on the way I purchase eggs and milk from farmers. Yes, so also it is combined with some local hipster shopping of stuff, not from grocery stores, but rather directly from the providers of those goods. Yeah, and that's my typical road. Yeah, but if I have more time, I really like to visit Heidelberg, Speyer, and Mannheim. It's about 80 kilometers. Yeah. Yeah, and also Pfalz. It's really yeah. So there are many amazing areas here, yeah, and as I said, yeah, this area is quite diversified, yeah, and I enjoy variety.
And it's something that I truly love doing, cycling. We talked a bit about that in our meeting we had. So I also love cycling, and with the Institute for Sport here, there's also a cycling group. So students can also look forward to that if they're into cycling, if they're new to cycling. Well, thank you very much for taking the time today. I was super fascinated to hear about your takes on big data, statistics as well, and how we can implement those in our everyday lives. So thank you very much again.
Thanks a lot for having me here. Yeah, it was a pleasure, yeah, and it was an interesting experience, yeah, that I must say.